Hey guys, so far we did our linear review and we were through the linear test part 2. Again, just hold on to that stuff, do the best you can with it. When we get back to some normalcy, we'll get a hold of that and continue. So now where we're heading is to scientific notation. So I'm going to put some notes down. I know today shouldn't be too bad, the 8.6. I want to go over the basic concepts of scientific notation. Angela's playing Xbox out there. And then tomorrow we'll get into a little bit more complex. Some of the things in scientific notation, the exponent rules, we're going to get back to if we get back into the classroom. If not, I'll try, once we get through scientific notation, we'll go into those exponent rules as to what happens with negative exponents and why. All right, but to get started today. All right, this was our warm-up from this morning, and if I posted this online, right, if you have 10 to the third times 10 to the fifth, if you just expand that out, it'd be 10 times 5 more would be 10 to the eighth. So we recognize, what do we do with these guys? We're actually going to add them. What happens to decimal point when you multiply a number by 10? If you multiply by 10, we know it just moves over one place. If you do it by 100, it would move over 2 places. If we multiply by 1,000, we'd move over 3 places. Same thing happens if we divide by 10. It would get smaller by 1 place, right? 100, we'd move it over 2 places. Think about percents when we do that stuff. And 1,000, you'd move it over 3 places. That's sort of the base of scientific notation. Okay, and then for the third one here, if I had this guy to figure out what exponent went up here to equal this, I would move it over. If it was right here, it went over 1, 2, 3 places, which means I took this guy, multiplied it by 10 3 times. Okay, so that would be 10 to the third there. All right, for that warm-up. So getting into the notes then. Scientific notation, what it is it's a way of writing really big or really small numbers in a small space, and it's much easier to read instead of trying to count all these zeros and all these numbers with these large, all these digits, okay? And this is an example of something in scientific notation here. There'd be my standard form. This would be my standard form. Scientific notation would be 7.42 times 10 to the negative 6. And the reason why it's negative, I'm going to explain in a minute. You could see this guy's positive. Notice how big it is, so that's a positive. This guy's a really small number. We have negative. So key concept number 1, when writing a number into scientific notation, that first number we have, or the number that we have that we're going to multiply by 10 to some exponent. Angelo, ease up, bud. I'm on video right now. Needs to be a number between actually 1 and 9 inclusive. So it has to be 1 digit. It could be a 1, 2, 3, 4, 5, 6, 7, 8, 9. Decimal point, then your other numbers, and then times 10 to some exponent. Okay, so these would be considered scientific notation. 3.605 times 10 to the negative 8th. So it'll be one number, then your decimal point, then whatever other numbers you have, times 10 to some exponent. What does this say? So number 1, so one number, sorry, not the number 1. So one number, then the decimal point, then the other numbers, times 10 to some power. These guys would be not considered scientific notation because you notice there's 2 numbers here, then a decimal point. The number's still good. This is still a good number. It's just not considered scientific notation, either with this guy. Okay? In scientific notation, we would have 5.63 times 10 to some exponent, in this case 6, or 4.0. And that's what we're going to do. We're going to learn how to move this decimal point around so that we get it into scientific notation. Okay, so that's key concept number 1. One decimal place, or one number, then your decimal point, and then your other numbers. Now, key concept number 2 is the value of the exponent for the 10 tells how many places to move the decimal point, because we're either going to be multiplying by 10 a whole bunch of times or dividing by 10 a whole bunch of times. If the exponent is positive, the decimal point is going to move to the right if we want to put it into standard notation. So if I had 5.3 times 10 to the 6th, that's basically saying it's 5.3 times 10, 10, 10, 10, 10, 10. I wouldn't write all this out. The point of scientific notation is just take this guy, move it over 6 places to the right, 1, 2, 3, 4, 5, 6, put my decimal point down, fill the zeros into those values, and you see either way I'd get that same answer of 5,300,000. Okay, so if it's a positive exponent, it's going to make our number bigger, and if the exponent is negative, okay, we're going to move it to the left that many place values. Okay, so we're not going to change the sign of the number. That exponent doesn't do anything with the sign of the number. It actually is telling us to divide instead of multiply. Okay, and again, this is what I was talking about earlier. We haven't gone over exponent rules yet. We'll get into them, but a negative exponent tells us to divide by that number that many times. So that's the same thing as saying 5.3 over 10 to the sixth, or 5.3 divided by 10, 2, 3, 4, 5, 6. That's what would happen. And this would just, if you divide by 10 one time, it moves over 1. So if we're going to do it 6 times, you would take this guy, and we took 5.3 and moved it over 6 places this way. 1, 2, 3, 4, 5, 6. And then I just go ahead, and each of these little gaps, I put a 0 in there. Okay, and then that would be my standard form right there. So a negative exponent means to divide instead of multiply. It does not change the sign of a number. So if I had 6.34 times 10 to the negative third, that doesn't become a negative number. We just divide by 10 3 times, make 1, 2, 3, fill in your zeros, 0.00637. Okay, that's what I would like you guys to practice today. So on your 8-6 paper, okay, it gives you some reteaching. So what do we do then on these problems where it says to write in scientific notation? Basically, if it's a really, really big number, we're going to have a positive exponent. And if it's a really, really small number, we're going to end up with a negative exponent for our 10. So what I would do then is write this as 5.75 times 10. And I just think, how many places would I move how many times would I have to multiply 5.75 times 10 to get back to this? So I just count. It was 1, 2, 3, 4, 5, 6, 7, 8. So I'd have to move this 8 places bigger, so that becomes 10 to the 8th power. If I start with a really, really small number, I know my decimal point is going to go into here, so it's going to be 9.8 times 10. Now think about, if I want to go from here back to that, it would be 1, 2, 3, 4, 5 places, so it'd be to the negative 5th power. I'd move it that way 5 times. Okay, the standard form is just what we were doing earlier. If I had this guy, so now I'm going to take this 8.2, which is right here. The 2 is right here. Since it's negative 6, I would move it over 6 places. 1, 2, 3, 4, 5, 6. Fill in zeros, and there's my number, 0.000082. All right. So from that point, I think you should be able to go forward and answer your 8-6 packet there. Tomorrow we'll move on to the 8-7. I'll post answers to this stuff as well for you guys to check your work on the e-board. So continue to monitor the e-board, and good luck with everything. Hopefully at this point everybody's hanging in there, doing well, and able to get their work completed as best they can. All right, guys. I will see you tomorrow.